Right. Good. So first we do the completing the last day's problems, right? So let's go look at the first problem, which was not complete. So that was about arrangement of cards, right? So problems from previous day, problems previous day. Number one was card arrangements. So this time we'll keep the discussion brief, okay? Because now, yeah, if you have not thought more, then you should have. Okay, card arrangement. Then you have to think later. But anyways, let's see. Yeah. So we had initially this 2 copies of each card. Card one also we had 2 copies and so on. And I don't know how, yeah, 9, 20 cards, 9. Okay. Now the question was, is it possible to arrange so that there are no cards between the cards labeled 0, 1 card, no cards between card labeled 0, 1 card between cards labeled 1, and so on. Yeah. Is it possible? Is this possible? Yeah, that was the question. So has anybody? Yeah. Right. Then it is possible, right? That's what you're saying. Yeah. Yeah. So we had said that if sum, what sum? Yeah. So if the sum, so this sum will be like in our case like 0 to 9. Okay. If the distinct, or rather I would just say that if the distinct sum, if the sum of distincts, yeah, that's how I should say, because the total sum will obviously be even. If you're taking over all the cards, then will obviously be even because everything is apparent twice. Of distincts is even, then is even if and only if such arrangement is possible. Yeah, I mean, it was kind of look like it is both directions. It looked like it is both directions, because we had seen that whenever the sum was coming out to be odd, then it was not, seemed like it is not possible. But more surely when the sum was even, then it was possible. We had seen. So then here the sum is odd. Yeah. So that's all you need to know to just to know the answer at least. Yeah, this is important. So obviously 1 to 9 or 0 to 9. This is odd. So how much is this? 45. Yeah. So this is odd. So at least for this, now we'll just focus on answering this question. Okay, just this question. So now let's explain, but then why? So all we need to explain is that if the sum is odd, then it is not possible. So let's not focus on both directions and so on. Let's keep it simple now. And if the sum of distincts is odd, then not possible. But how do we show this? Or if the sum is 45, then it is not possible. It has to do something with the sum. So we are only focusing to show that if the sum is odd, if the sum of numbers is odd, like 1 to 9, then it is not possible. Let's not forget about the other things. Sum, no, but yeah, sum is the key, but invariant under what? Like, what are we doing that it is invariant under? That is not so clear. So no one has idea? Yeah, Unab, Nagesh, has you guys thought anything? How would you show that? How would you use sum? Just think of how you would use the sum in this arrangement. So you have to imagine if this arrangement was possible, then how will the sum feature in? Any ideas? If the arrangement was possible, then how would the sum come in? Okay, so let us see. So since nobody has idea, let me, so this is not my idea because I didn't actually think about this question too much, but either way I may have not got it. But this is the idea which I had seen in the solution. So it's not my solution, but very simple idea is, let me just say it in a loose way. Let's first mark the positions. Okay, positions are from 1 to 20. Okay, now you see, if such an arrangement was possible, then the zero, the two cards that are labeled zero, they will go in two of these 20 places. Is that right? Yeah. But there is a connection between those two places, right? So let me write it here. So on this, I'm here writing if, yeah, if the first card zero, or so there are two cards which are labeled zero, right? One of them will come before the other, right? So if the left one, if the first card, if the first card labeled zero, if the first this card is at position, what position we don't know, so we'll just say some position a of 0 or p of 0, position of 0, we don't know that position. Yeah, but if this arrangement is possible, then it will be somewhere. Let's say, I mean, it could be 4 5 anything, right? So some p0 position, and here we have placed. Then where will the second card be? Where will the second copy of the card 0 be? Yeah, but here by left I mean, by first I mean leftmost. Okay, p0 plus 1, right? So this one will be in p0 plus 1. Okay, so just check, is this notation okay with everyone? Yeah, Unab and Pragdish, is this notation fine? Because there's some notation which is you have to, yeah, because without these notations it becomes, yeah, it becomes cumbersome. Okay, but now you can understand that this, I mean, I could have, yeah, actually there is a better way to say it, but 1 minute. One second. There is a better way. No, I was just thinking that if I just focus on the difference between the two positions, then that is much simpler, right? That, like, to explain that, I don't have to put a label of position and so on, right? Though no harm in putting labels, you have to be comfortable with this. But I'm just thinking, so then the difference between the position is 0 or 1, and for cards labeled 1, the difference between the positions will be 2. But this difference may not be useful, right? It's the sum of the positions that we have to make use. Yeah, or maybe 1 minute. So if the position, these are the gaps. Yeah, then I don't really get anything. Then it's just the translation of the question. I don't really get anything. Right. Yeah, and those differences don't have to add up to anything special or anything, I suppose. Yeah, so that doesn't seem good. So we have to do it like this, I think. Okay. So if the leftmost copy of 0 is at P naught, then the other copy at P naught plus 1. Okay. And so similarly, what will be for 1? If the leftmost one is at P1, then the next one will be at P1 plus 2, right? And like this. Okay. So these are the positions. Okay. So in this way, we'll get this sequence of numbers. Yeah, I hope so far it's in sense. In this way, I'll get this sequence of numbers. Yeah. So what is the sequence of numbers? A sequence of positions I will get. I have, I don't draw this, sorry. I will just say I have P naught plus 1. Then we have P1, some position, any position, P1 plus 2, P2, P2 plus 3, and like this, P9, okay, and P9 plus, so what will that be? 10, right? So these are my positions. Now you think, so just take a few minutes and think, what can we say from it? So these are all the possible positions, if such an arrangement was possible. Okay, just think, I'll just drink some water. Okay, so what can we say from here? What can we say about this list of numbers? Something special about this? If we add them, it will be odd. Yeah, but more than odd. Yeah, it certainly will be odd, but this number should be exactly equal to what? No, but no. Okay, that is no. So why should it be odd? And so why should it be odd? Sorry. So you are saying it is odd because you are adding it like this. Just adding. Okay, that's perfect. That's perfect. That's perfect. Yeah, this is an odd number, right? Odd number because you see this is even, and you can check. Hey, that's no wait. What happened? It's right. It's odd because 1 to 10 the sum is odd, right? And this is even, so this is odd. Odd. So this is odd. We don't know what the sum is, but we know it is odd. Okay, that is the thing. But then what's the problem with this being odd? Like, why is that a problem? Right, we have even number of cards. There are 20 positions. So you are saying the positions, there are 20. So let me write that. There are 20 positions. And what are their numbers? 1, 2, 3. These are the numbers of the positions, not the cards, right? 1, 2 till 20. All right. So these are the possible positions. Okay. And what are these? These are also the possible positions, right? These are all the distinct possible positions. Okay, so just note that because there are an even number of cards, that is not even enough. There are even number of positions, that is not enough. There are 20 positions, that is I feel that is a difference maker, right? Because these 21 to 20, this sum is even, right? So that is the thing about the number 20. This is even, so this will be 2 times 54. Okay, this is even. So you see what happened. Yeah, this thing, these are the possible positions. In one way, they are the possible positions from 1 to 20, so some should be even. But in another way, if we just add them, like just add them, right? Then that sum comes out to be something odd. And that is, so so that is just apply the formula. So it's 20, or is it not correct? 20 into 21 by 2. No, so it is not correct. No, it's not 2054. Sorry. It's 2055. Is that right? No, it's not even that. What am I writing? Yeah, it's just something even. It's 20 into 21 by 2. Yeah, this is even. 210. Yeah, right. Yeah. Okay. So it is basically the sum of the positions that we are adding in 2 different ways, and we're getting a problem. Okay. So it's a little tricky question. Little tricky, okay. But yeah. Yeah, and I don't see any other way. There are some ways I thought, but they don't work. Okay. You can think of some other way, then yeah. Because you see, the problem with this is that there are so many different arrangements that are possible. There's I mean that there are so many ways to try this out, right? So many ways that you can arrange these 10 cards in 20 positions, right? That is really, that's why it's hard to like do a reasoning which is based on, like all possible arrangements, something like that, induction or something. That's why we have to, pick out some very simple obstruction. For a very simple reason, it fails. For a very subtle but simple in the sense that it doesn't need too much. But yeah, that's why it's hard to find maybe. Okay, so this is the thing. Now the next task is to show that for even numbers, yes. Yes. No, yeah, you can say that, but really, I will not call it an invariant. Rather, I don't even see if this is an invariant problem anymore, because, I mean, it can be said, but the point is that we are not really doing any action under which something is not changing, right? Like there is no there is no active action being done, like taking a card and shuffling it, and something is not changing. That's why I'm not finding it hard. I'm finding it hard to say invariant. Okay. Yeah. It's more like this is a very incredible topic which we will not be doing soon, because it's a little double counting, which you guys can, if you have just time, just to explore. I mean, you'll find this this will be there. And yeah, so if there is a very beautiful book by, but again, little advanced, T2 and Risco. This, because many books have this chapter, but this book has like a, from what I remember, very nice. So mathematical, but little mature topic. Okay, mathematical treasury, something like that. Something mathematical treasury. Just Google it. Another place where this is very well done, very well done. In fact, this is like that. Right? We are counting the same thing twice. Just like our accountants will do, count it like this, and then count it like this, and they get the same thing. Right? That's how they check, right? That it is the sum is correctly. People used to do that in the olden days. Count, and many problems are based on this. Many questions. Okay, maybe I could say the sum is the invariant, whether you count like this or count like this, or you count diagonally, or whatever. Yeah, it doesn't. Maybe that's. But the other thing which you can look at is, but this book, I don't know, it's a little hard to get. Okay, I have a copy. I have a thing, but it is not complete. It's a strange old copy. Yeah, and this is intermediate count, not intermediate. So you can check both of them: intro to counting or intermediate counting. Intermediate counting. So this is the AOPS book. Okay, so David Patrick and the other guys, I don't know the name. Richard Ruzak. I don't know if he wrote, he was in it, but David Patrick was certainly there. So these two, one of them, probably intermediate counting has a chapter on double counting, and they do it very, because I was teaching one US, that time I had the passport, so I had the book access, but I won't buy this, it's too costly for me. If you have the money, you can buy it also. If you buy it, it's a good investment. Okay, it's a little costly, 5,000, but then it has everything. Okay, so yeah, it's a very good book, but you don't need to, because this book has very incredible problems, and you can get this. And I guess other combinatorics books will also have double counting, but we will do it, but later. But this book also, Tito's book, is very good. Okay, so maybe I'll do some problems. I can't think of, I can think, but then they become a little tricky. Yeah, so let's not go into them. No. Oh, no. So here I wanted to ask a question. Yeah. Now, if I make this, let's say I make this to 8. Yeah. Now we want to show that it is possible. Yeah. Let's do this. This has a lot of utility. That's why I'm doing this one. So show that it is possible. So this reasoning will be completely different. Yeah. You'll have to make it. And it's, I think, a lot of interesting thing. Show that the previous mentioned arrangement is possible. So last time, especially Aparna, I think, was giving us good arrangements for the small numbers, at least till 4, I think we got. So by 12, you mean from 1 to 5? Yeah, but for 12, you will not get, right? Because the sum is odd. Right? But for 14, if there are 14 cards, So if there are 14 cards in total, then it means the number is from 1 to 6. And for that also you will not get because sum is odd. Okay. So so that is fine. That is you cannot get. So that is okay. So then the next thing is 5 plus 1, 6 plus 1. So let's do it till 7 then. Yeah. 16. Yeah. So that's 7. So yeah, 7. So then let's try this because this is possible. I mean, it's at least it's not excluded in our thing so far. So sum from 1 to 7 is even. Yeah. So let's try to make an arrangement. How should we? So the zeros we will place. So what do you think? Let's try. Let's try. I'm just trying. So you don't have to look at this. You can try. Seems I know. Yeah, seems very tricky. Seems ad hoc, right? This one, so it may be a hard question, so I don't know. Anybody got? Um, You can also try for 4. I mean, till 4. You can also try for 1 to 4 if you have to. Oh, nice. Okay, tell. So how is where is the 5? Leftmost. Nice. 5. Mm-hmm. 6, 1. Hmm. 4, 2, 6. Okay. Wonderful. Wonderful. Yeah, like as we know, one position determines the other, and this is correct also. Yeah, is it correct? Yes. If anyone finds, no, just this. You see this arrangement? Yeah. No, Unab. So just the arrangement. You see, this is the right arrangement. Yeah, like you can see, right? So the between, it's incredible. So you see, it's so. How did you come up with this, Ishana? Is it just trial and error, or? Hmm. This is very good. This is one of the key things that you have to do to be a good problem solver in the beginning stages, at least. Yeah, like how would I think of putting 5 in the leftmost? Ye- Huh. Sorry, say again. Huh. Yes. You're saying the 5 to 5 is independent from 7 to 7, but that is not clear why, right? Why not? Because I mean, one a priori one does not know. Like it could be a 5 like this, and there could be a 7 like this, and then a 5 after 4 places, and then some 7 again after 1 place, something like that, or 2 places. Yeah. I mean, I may be wrong. If this is the only arrangement, which I don't think it is, it's very nice, right? We don't know anything about this thing. I was thinking about splitting. I was thinking that like it won't matter if I put 0 in the leftmost or something like that. If I put 0 in the leftmost, can I always put 0 in the leftmost? What will that mean? Let me think about this. Yeah, because otherwise it's because we have limited time. Let me think about it. But this is very good. Aparna, do you remember the how you did for 4? I think last time you had done. So can you, yeah, just say because maybe some connection. Yes. Hmm? So yes, the 0 is on the left. That's what I was thinking. 6 depends on. Two different sections with depends on. In this case, it is split, but the 6 is not split. Yeah, that is certainly good. But Nagesh, about the splitting thing, so when you mean 6 cannot be split, what do you mean? Like split with respect to what? Ah, oh, no. Yeah, that seems, yeah. Even between 7 to 7, it's not independent. Like one in 6 is inside. Yeah, so that I think what Ishana has said. So what I was doing initially was like, so 0 and 0 is the wrong thing to do, right? So Ishana, that's what you're saying, that you should first focus on the biggest numbers, or is it? What is the advantage of focusing on the biggest numbers? In roughly speaking, 7 and uh, automatically. Right. Okay. That's a good, very good. Yeah. So she's saying that because there's a large gap in between, and when you fill them, then the things outside also get decided. Yeah, that's very nice. Yeah. Hmm. Huh. Yes, yeah, that's right. Yeah. So we don't, no, the 6, yeah, yeah, we don't know. Like one copy will be to the right or one to the left, or yeah, we really don't know. But so try, I mean, all of you can try to do. I was trying to connect this to also, and I'm not able to. So I don't know. Mm-hmm. Okay, then that's a good thing. Let's see. Mm-hmm. 5 2 7 3 2 6. Okay. Wow. Okay, just come, just everybody just check this is right, because I mean, and then we'll try to compare, find some common feature. Correct. Is there some common feature? Yeah, 1/6 is in the 1/6 is in the middle, and the other 6 is on the left. But yeah, there is really no common feature in that. This maybe tells us there are many arrangements like this. I don't know. I don't know. Yeah. So I'll think about this. You guys also think, if you can find something, tell me. Okay. You guys can find much faster. Okay. In the sense of maybe at least create much faster. Maybe you won't see the pattern, but do it. Yeah. So sorry. Say that loudly, louder. 6 and 3 together. No, but 6 and 3 is not together earlier. Oh, acha, 1 6 and 3. In the other one, is there and 7 and 3 also together. There is no, yeah, we're just trying to we're just trying to find a pattern, but there doesn't. Yeah, so maybe there are many. So I will think about this. Okay, I will definitely think about this. This can be interesting. Okay. Huh. No, but there could be a pattern of a very different kind, some sort of a reflection, you know, yeah, something like that, So, but yeah, so you know what I'm saying, right? So if you like, so what I'm saying is like there are 20 cards, right? So for example, you can take this arrangement of 20 cards, just like right here, these 20 cards that are okay, there's 14 cards, sorry, or 16 cards. You can go to the 1, 2, 3, 4, 5, 6, 7, 8 here, and you can reflect this. Just reflect it. Will it still be a legal arrangement? If I reflected about the middle line, yeah, it should be right. So like, yes, yes. Like if I, the 7 and the 4 and then 2. So I'm just writing it in the opposite way. This will also be the legal arrangement, right? Or will it not? 4, right? 3, no, I missed something. 7, 4, 2, 3, 6, 2, 4, 3. Huh? What is happening? No, so then, anyway, so I mean, anyways, you understand. Yeah. I mean, the point is that this will not change. This will still be a legal arrangement, right? Because I mean, it's like a reflection, right? And reflection doesn't change distances. I mean, it's not like this. Yeah, it's a reflection like this. It doesn't change distances, right? We all know that. And that's why this under these isom under, so we can think of some geometric things which we can do to this line, which will not change, and that will give us more and more, right? So 2, and so upon this example, we'll give another one, so we'll get 4. If we got 4, and so whenever the answer is x, then the answer is 2x. The answer should be an even number, unless if the palindrome, but the palindrome will not work. Like if something, if symmetric, that is not an arrangement. Yeah. So if basically something is an arrangement, then we get another arrangement for free. So all those things are there. So that's why I think there are many arrangements. Yeah. But anyways, I'll think about this. This can be interesting. Basically, it's a special kind of permutation. Yeah, it's a special kind of permutation with repetitions. Okay, that's what it is. Okay, and this you guys will find it hard. It's to do, but maybe you can see. But what I want you guys to think about, I think this is the easy thing. So we spent a lot of time today, so we'll not try to not do like this next time. But still, what I'm just saying is, what I was focusing and I failed is how to use the arrangement of the cards from 0 to 4 to make an arrangement for cards from 0 to 7. Somehow build, yeah, please think about this. Yeah, like make an arrangement from 0 to 4, and can you place cards in somehow, in some way in between, you know, I don't know, with some placing and some kind of shuffling with some, rule, by some rule, will again give you an arrangement for 7, and then using the arrangement from 0 to 7 to get the arrangement for 0 to 8. That will be, then you'll have an algorithm to build it. That's very important. Okay. So anyways, let's continue. So today we just spent a lot of time on this. Anyways, it's a little hard problem maybe, so it's okay. So then let me not go to the number theory thing today. I'll today keep the class today short. Next time we'll start at 9 and do longer class. Yeah, so the next question is about so there were two more. One of them was kind of solved, but the other was the chocolate, right? Chocolate, yeah, chocolate bar game on chocolate bar. Yeah. So we were allowed to divide and we were allowed to eat. That was the thing we want to do. So let's do that clearly so that even if some of you have solved it, you would know how to say it clearly, right? It's very important. Also, I forgot to say this, but coming next month, by the end of next month, I will be splitting this class into 2 batches. Okay. So one will be slightly and one will be slightly. Okay. According to how I see the performance. Okay. It will be, obviously you're free to attend both, but that will not be very useful. You should, yeah. So I will try to split it. Okay. Maybe if there are more people coming, we'll see, but we'll try to split. That's the main thing. Okay. So it will depend on your performance so far, and also maybe 1 or 2 tests will come in, and okay, comfort level, because then it will be more challenging. And let's see, because now the this batch which I have, the ISI batch, will go out, then I can have more space. So there are this 4, and then there is 5 and 6, maybe 7. Okay. Okay. So we have 7, and here we have 1, 2, 3, 4. Yeah. And again, at each step, pick any available piece. Pick any available piece. Okay. Break it into 2 pieces, arbitrarily into 2 pieces, or eat it. Okay. So what was the game? So 2 players. So A starts. Yeah. Moves alternate. What was the condition? The one who cannot make the last move, right? One who cannot, well, let's keep it cannot make the last move loses. Yeah. So yeah, so basically the person who eats the last piece of chocolate wins. I don't know if this question has changed, but we'll try to do this. So there are 2 kinds of things that you can do. That's the difference in this question. No. No, but it is not just about the breaking. Maybe you're right. No, that is not correct. Because when the breaking ends, then some chocolate pieces might have already have been eaten up. Is that right? You don't really know. Yeah. That's why it's different. Yeah. So if it was not about the eating thing, then obviously we know that the game ends in 27 moves, and so A will be making the last move, right? A starts, and so A will be also making the last move because odd number of moves, and so B will be when the B's time comes, he has nothing to move. So that is easy. But this time it's also, but let's think about this. And that was like very easy in the sense that it was not even a game. It was just a fate. So, I mean, if A wants, so basically A wants to eat the last piece of chocolate. Yeah? So what should A ensure at each step so that, he ends up eating the last piece of chocolate? So A will leave 0 chocolates for B. That is the thing. Yeah, that is certain, right? So A can just in the beginning, A can just in the beginning eat this whole chocolate, right? And then he wins. Yeah. So it should be then be the person who makes the last move. No. Oh, well, so who makes the last move loses. So the question has changed now. Okay. Who makes the last move? So who basically, I mean, last move means who eats the last piece of chocolate loses. Okay, whether it sounds strange or not, I don't know. But who eats the last piece of chocolate loses. So the question has changed, obviously. So yeah, this is the question. Okay? Because obviously, otherwise they could just eat, and he then makes the last move and wins. Eat the whole chocolate. So now A would not want to eat the whole chocolate. So in the beginning, he'll break it. And he can break it in any way, in the sense that he has to just follow the grid lines. Like this he can do. Okay. And he can, you guys think I'm just drawing a first step. So I didn't get it. Yeah, you mean no, not 28 pieces. Why? Because yeah, they will in the middle they can eat, right? Or I don't know. Yeah, they may not as the for some strategy purpose, but a priori they can eat in the, yeah, in the middle. But yeah, in every move you have to either eat or so you cannot say I'm not going to make a move. I'm not going to eat or break. That's not allowed. Okay. When your turn comes, you have to eat even if it's the last with the chocolate. Yeah, otherwise the game never ends. Yeah. So yeah, you cannot leave. You cannot say I won't make a move. You have to either eat or break. Yeah. So see, basically the point is that, and this is the theme even in the next question which I had asked is, A always wants to leave at least one chocolate bar for B. Like after he is done making a move, he wants to leave at least one chocolate bar for B at each step. Yeah. At each step, he wants to ensure that there is at least one chocolate bar left for B. Then yes, so he will, I mean, he will want that so that that thing will carry over to the end, till the end. right? If A can manage this, then it will carry over till the end. And then in the end, there'll be exactly one chocolate cell, atomic cell left for B. And then he loses. Right. So this is the technique here. And this basically is like saying, I mean, at least one means what? It means, so to be more particular, he has to leave an odd number of pieces for B. Okay, so what A will try to do is at each step after his move is made, I think, I don't know if that can be, yeah, I mean, that's what I'm thinking, that after his move is made, he would want to make sure that there are an odd number of pieces on the table. Yeah, after he makes his move. But in the beginning, when he makes this move, then there are two chocolate pieces. There are two chocolate bars. Yeah. Say louder. Say louder. Yeah, yeah. No, it will not be a disadvantage, right? In the sense that at least that's one way for him to win. If A leaves, no, B cannot eat four of them. How can he B eat four of them? B has to eat one. Right. And B has to eat one, right? I mean, I'm trying to say that to win, any player who wants to win, right? The player will want to leave odd number of chocolate pieces. And A is not able to do that, right? A will end up leaving two chocolate after the first move. Yeah. But then you look at B. If B eats this up, then for A, then when A's move comes, so this is what A does. This is what A does, right? Now when B moves from here, yeah, B will either end up eating one of them, in which case you'll get one piece. So that's one piece. Or B will end up breaking one of them, in which case you will get three pieces. It is B who is winning, kind of, right? Because when B is making a move, and actually no matter what he's doing, whether he's eating a piece, how he's eating, that doesn't matter. Or whether he's breaking a piece, how he breaks doesn't matter. He is leaving an odd number of pieces. Okay, now you see, no matter what A does, if there is only one piece, if A follows up with this one piece thing, then he loses. All right, I mean, if he eats it, then he loses. If he doesn't eat, then again, he will leave two pieces. If he divides it, then he'll leave two pieces for B. He can never leave odd number of pieces, right? So even when there are three pieces, he eats one of them, he leaves two pieces for B. He divides one of them, he leaves four pieces for B. So two or four. But then again, B is in the same good position. He has even number of pieces. So he will again leave an odd number of pieces. So B always leaves an odd number of pieces, right? So when it comes to the last moment and B leaves an odd number of pieces, it will mean B leaves one piece. And that will be atomic cell. Yeah, which he has to read. I mean, if it is not, then A divides it. But again, eventually, B will leave one piece, which is atomic piece. And at that point, he will lose. So this is the strategy. Yeah. So usually you see this maintaining this parity as the invariant. It is the parity which is not changing, because this is not an ad hoc game. It is a simple game. It's a example illustration type game, right? So, and even in a lot of problems, it's like, yeah, there's a simple invariant which we have to maintain. And this is the thing.
So when you eat the last piece, you lose, right?
Yes. Yeah, because making the last move, and the last move has to be an eating move. Huh? So you think no. So if there are 28 pieces, then that no, but that really yeah, so if there are 28 single pieces, it means no one ate anything in between. Right? So then there are 28 pieces, and that was 27 steps. Now who will start eating? B will start eating. And then you see that way also that's a simple path, and that way also A has to eat the last piece. But what we have shown is no matter how, yeah. So it's like that. You see, whenever it's like this, like the last move, who makes the last move, then you have to see. Like making the last move means having one piece. So who left the one piece? So someone who leaves one piece. So someone who leaves odd piece every time is the winner. So you have to analyze and see who can. Okay. Yeah. So the other question which I had asked, think about that. The last question which there was again a chocolate question. Try to think. It's also similar, but maybe different. It's not hard or easy, but it is little different, but similar. Yeah, you can see. Okay. So if there are any questions, then please ask. Otherwise, we will stop. And you guys have to confirm me about Wednesday. If I get no confirmation, then the class will be on. If I get no messages regarding any problem, then I will do it on Wednesday. If I get, then I will try to change it to, I think Munab said Saturday, or Saturday is okay. But we'll do it from 9. Okay, that is certain. Okay. Okay then. Thank you. Good night. And yeah, try to do things in the morning. Yeah, like if you can want to try these problems in the morning, it's much better in the long run. Yeah. Okay. Good then. Okay.